So let's have a look at some examples of functions. First I'll talk through an example and then we'll actually have a look at the code. So functions are very often mathematical in nature. They perform a mathematical operation and return the result of that mathematical operation. So let's write a simple function that will return the square of a number, i.e. the number multiplied by itself. So here's a simple program which we'll see running in JustBasic in a minute. We just have a loop just to enable us to use the program repeatedly. Clear the screen, output a little message saying what the program actually is. Have an input statement that gets a value from the user, and then this is the bit of code that actually does the business. Square val equals square function open brackets SNG value. So here we have a bit of syntax difference between procedures and functions in JustBasic. Functions have to have parentheses within which their parameters are entered, whereas sub-procedures have parameters just in a list separated by commas after the sub-procedure name. But because functions can actually be part of a bigger, more complicated statement, then the parentheses are syntactically required to be able to identify where the parameters actually are, and to be able to distinguish between square function as a variable name and an actual function name. So this variable square val will be assigned the result of whatever square function returns, and square function is passed a single value, SNG value. So let's have a look at the function down here. So it starts with the keyword function. There's the same name as here, it's exactly the same name, square function, and again the parentheses indicate that it is a function and that we have some parameters. If we have no parameters, we still need the parentheses, they'll just be empty. So the variable that we pass across is given a local name here to the procedure, to the function, of value, and value multiplied by value is what this function does. That's the square of value, and that is assigned to the function. Okay, and that causes the function to end, and that result then ends up being assigned to this variable square val here. So let's have a look at that program in operation. So this is the program that we were just looking at. Let's first of all just run it and see if it works. So hopefully you know that 10 squared is 100, so 10 squared equals 100. Let's run it again, and hopefully you know that 0.5 squared is a quarter, 0.25, sorry, 0.5 squared is a quarter. So we know that that program works. So let's step through it and see what's happening. So we'll use the debug tool, and we will see what's going on as we step through the program. So step in, and we can see that we've got our variables up here, currently have no values in them. Clear the screen, output our little message, a blank line, an input statement to ask the user for a number. So we'll input 10 as we did in our testing, and we can now see that that 10 is assigned to the variable SNG value via the input statement. If I just scroll to the end of that line, you can see that SNG value is the variable into which the inputted value is placed. We then come down to the square val function, and here we need to make sure that we step into the function. If I step over the function, then the debug will just proceed to the print statement. If I step in, then we'll actually jump down to the square function. So we can see here that we're going to be very shortly switching to a function, and our list of variables at the top will change. These are the variables local to the function. So there's the function itself, which currently has a value of 0, and then there's a value that we passed in which is currently 10. If we step over that, we can see that square function has now been assigned the value of 100, which is value times value. We can then complete that statement. Execution returns to the point at which we call the function, and square function is now being given the value 100 from that sub-procedure from the function, sorry, not the sub-procedure, which will then be assigned to this variable square val. So we can see that that variable, that value of 100 has come across. We can then output that value to the screen and continue with the program as normal. So you can see there exactly what's happening. So let's go and have a look now at another example. This time we'll use an example that has two parameters, so we're passing two things in. So we're going to calculate the area of a rectangle. So we'll pass in the length and the width. So again, very similar program. We have two input statements this time, taking in a length and a width, and our function call is a different function. It's called rectangle area this time, and it has two parameters separated by a comma, just as we would with the sub procedure, and we pass across the parameters SNG length and SNG width. We can jump down to the function here. So here's the function rectangle area. There's our two parameters. Locally we'll call them length and width, and rectangle area, which is the function, is assigned the value of length multiplied by width. So if we go across to JustBasic, I'll just delete that program and copy in the rectangle program. First of all, let's run it. So we'll say a rectangle 5 meters by 6 meters, so hopefully the area will be 30 meters squared. Okay, so we can see that works fine. We'll just test it again with one that is 1.2 meters multiplied by 4, so we should get 4.8 meters squared. So we'll end that, and we can step through this program just to see again what's going on. So if we step through, we'll be asked to input first of all the length, so we'll input our value of 5, and that will be assigned to length. We'll then put in our 6, which will be assigned to width. We can then jump into the function rectangle area, pass across SNG length and SNG width, which are 5 and 6 respectively. So jump into our function. So our local variables change. This time we've got 3. We've got length and we've got width, which have got the values that are passed across, and we've got rectangle area, which currently is 0. It's now 30, which is the result of length multiplied by width, and that 30 gets passed across back and gets assigned to rect area here, and we can then output that statement to the screen so the user can see the answer is 30 meters squared.